All right. Your parents, they're saying, suppose this, so it's a compound interest problem. But it says, suppose your parents invest $1,000 in a savings account for college at the time you are born. The average interest rate is 4% and is compounded quarterly. Okay, that means every 3 months, so that's going to happen, like they said in the previous page, 4 times a year. How much money will be in the college account when you are 18 years old? Okay, so we have to use our formula of A equals P1 plus R over N to the power of N times T, and fill in everything we're given. Well, A is the amount that's going to be there, so this is unknown, or this is what we're trying to find, A. P is the principal, so the initial investment. In this case, initially $1,000 is invested. So we're going to plug 1,000 in. And then it's going to be 1 plus. R is the rate, which is 4%, but I can't put 4%, so I'm going to put 0.04, which is the decimal of 4%. And N is the number of times it's compounded, if you remember correctly. So N is 4 in this case, and then N is still 4 up here, and then T is the time that it's going to be invested in years. So in this case, 18 years. The error here, I already know it. It's not going to be setting it up for you guys. It's going to be an error in the calculator when you're simplifying it. So do follow your order of operations. Do what's inside the parentheses first. So we're going to do 1 plus 0.04 divided by 4, but 0.04 divided by 4 needs to be in parentheses. It should look like that when you plug it in. 1 plus parenthesis 0.04 divided by 4, close your parenthesis. Hit enter, and I get 1.01. All right, and then it's raised to the power of 4 times 18, which is 72. Okay, the next error I'll see you guys do is, again, not following your order of operations. Remember, so here's our exponential function. Y equals A times B to the power of X. Notice the only thing raised to the power of X, though, or in this case 72, is at 1.01. So we need to do the exponent, and that means 1.01 to the power of 72. Okay, which I get like 2.047099.312. It's an irrational number. It's going to keep going on forever. So we take that and we multiply that by our 1,000 then. So after 18 years, this person will have $2,047 and what looks like 10 cents to their name, and that's only initially investing the $1,000 and not touching it, not putting anything else in, which really isn't terrible. Let's say your parents do this and you didn't know you had this money, so you find out when you're 18 years old that all of a sudden you have $2,047 from $1,000 that just sat there for 18 years. Not terrible. Now, is it a lot of money? Is it going to help much? No. In reality, if your plan is to go to college at this point, that's not going to help much. If your plan is to go into the workforce, then heck, that could help quite a bit, because it can pay for uniforms or whatever you need to go into the workforce. Or it could be a nice first month rent for you if you want to get the heck out of the house. So, like I said, compound interest savings rates, they're not going to give you the most money when you're done paying on them, but heck, you just gained $1,047.10 for just doing nothing. So that's a pretty cool concept. Another place we can use exponential functions is calculating car loan payments. So we'll see that in the next video.